All right, Pythagorean theorem, lesson B. So hopefully you've already watched lesson A, and are already aware about the Pythagorean theorem. So in the last lesson, given the two sides, A and B, what they call legs, and the hypotenuse, we know Pythagorean theorem says c squared equals a squared plus b squared. And what we did in last lesson was we solved for c squared. We solved for c, I should say. And c just came out to be the square root of a squared plus b squared. But what if we were missing one of the legs? Now remember, the legs are interchangeable, right? So like, I called this a and this b. There's no law I couldn't have called this b and that a. The a and the b can be either one. So, here's what we need to do. I'm going to go through and show you how to solve this for one of the legs. We'll say we're going to solve it for a. So I have c squared equals a squared plus b squared. I need a. So we're going to get a by itself. First of all, let me write it like this. A squared plus b squared equals c squared. Nothing wrong with that. Just switching their sides. I want a squared, so I'm going to subtract b squared from both sides. Now, I can't really subtract it straight away from a c squared because they're different things. So all I really can do is kind of tack it on here. They cancel over here and make 0. So I have a squared equals c squared minus b squared. And just like up here, to get the variable by itself and not squared, we take the square root. Of both sides, I should say. There we go. Square root of both sides, which is going to give me a equals the square root of c squared minus b squared. Remember, we can't, if there's a plus or a minus here, we can't break up that. This is the best we can do. So this is what we're going to use whenever we need to find one of the legs. One of the non-hypotenuse parts of the right triangle. So we're looking for a leg. In fact, here in this, I just used the term L for leg. So let's do that. Let's be consistent. So the leg that I don't know is going to be equal to the square root of, let's see, let's call it c squared minus b squared, the leg I do know. So this leg is what I'm looking for. So this right here. So first of all, I got to identify the hypotenuse here. Which one of these two is the hypotenuse? Well, the hypotenuse is always the longest side in the right triangle, and it is always opposite the right angle. So here's my hypotenuse. So when I'm doing this one, it's going to be L equals the square root of 37.6 squared minus 17.2 squared. So, just work this through in the calculator. Take our time. So 37.6 squared, remember that's this button right there, minus 17.2 squared. Don't forget to hit equals. Then take the square root of that. This button right here. There we go. 33.44. This 5 will bump that 3 up to a 4. So 33.44. So L would be 33.44. I think I should have written this 17 here and the 33 here, and the 33 should be here. Yeah, so Sometimes don't mind the fact that it may not look right on the triangle, because I could have put numbers in wrong places. But I'm pretty sure this is 17.2 and this would be 33.44. Just looking at it, this looks closer to that. So yeah, I'm going to go with that. So it happens. Okay, let's try one below it. So here, this is my hypotenuse. This is the other leg. This is the leg I'm looking for. So the leg I'm looking for is going to be equal to the square root of the hypotenuse squared, 21.9 squared, minus the leg squared, 15.3 squared. And we're going to work that through on our calculator. So I'm going to go 21.9 squared minus 15.3 squared, hit equals, then take the square root, and 15.67 we'll say. The 9 bumps that 6 up to a 7, which is where that comes from. Alright, so let's try this one. Hypotenuse is here. This is the leg. This is the one we're missing. So the one we're missing is equal to the square root of 4.1 squared minus 3.5 squared. So 4.1 squared minus 3.5 squared, hit equals, and then take the square root. 2.14 we'll say. 5 bumps that 3 up. So 2.14 looks good to me. There we go. All right, our last example, done the exact same way. So you should probably try to set this up before I do and see if you set it up right. Pause the video. Eh, 6.17 works for me. And it makes sense. It should be pretty close to this one. So yeah. Alright, so when you're trying to find a leg, this is the equation you're going to use. And remember, when you're trying to find the hypotenuse, the equation looks like this right here.